Okay, if you now turn to page 5, we're going to look at slightly more complicated expressions. So it says here, what about the sum whose R term is a quadratic or cubic polynomial? So we've got an example here, and if you what you might want to do is pause it and have a read through that example, make sure you understand what's going on. But I'm not going to go through it exactly step by step. But basically, we can see that if we've got something like 3r squared minus 7r plus 2, if we split that up, we can do some factorising, and actually we can split that up in such a way that actually this is exactly the same as 3 times the sum from r is 1 to 200 of r squared minus 7 times the sum of the r's plus 2 times, well, we've got it there 200 times, so if there was n there, it would be n, but 2 times 200. Or we could think of that as 2 times the sum of the ones. And then we can use the formula for the r squared, we can use the formula for the r's, and we get our answer on the 2 times 200. And so that always works. What we've got, we can split up our polynomial. So the coefficient of the r squared or r cubed or whatever goes in front of the sum, and then we've just got to multiply that by the sum with an n where the number at the end is, where there's just a coefficient. So let's use that idea to have a go at evaluating this here. So it asks us to evaluate the sum from 1 is r to 50 of r plus 1 times by 2r plus 3. So first thing first, we need to actually multiply out that bracket, because we can't use this rule up here while it's in this form. So what we want to do is multiply out that bracket, and we can do that. That's kind of quite basic stuff. And then once we've done that, we can split it up in the way as above. So that becomes 2 times the sum of the r squared plus 5 times the sum of, that's an r by the way, not a 1, and plus 3 times 50. And then we substitute those into the formulas that we've got. So we've got 2 over 6, because this one is 1/6, n times n plus 1 times 2n plus 1. And this one, because it's the r's, is we've got a half times n plus 1. So times that by 5, and with our 3 times 50 on the end. And then substitute that into our calculator, and we've got 92,375. So that's our first example. Second one is, we've just got to have numbers. We've just got to realise what is this talking about. So if you, again, with all of these, you've had one example. If you want to have a go at doing this one for yourself, you can do. Or at any point, if you think, oh, I've got the idea for this, I want to carry on, I've only got a time limit, so I'm going to get on with this. So this is, we've got 1, 2, 3, 4, etc. So that's our R. We've got 11, 12. So if we add 10, that's 10 bigger than the first number, and it's squared, so that gives us this. That's where that formula comes from. And same as before, when I multiply that out, I've done it in 2 steps to make it easier for myself. So I've done the squared first and then multiplied it by the R. That gives us this formula here. And then same as before, I'm going to split that up. So we've got the sum of the r cubes plus 20 times the sum of r squares plus 100 times the sum of the r's. And then we substitute it into the formula, which it will be here somewhere. There we go. Substitute all the numbers in. And yes, I am showing that I'm substituting those in. You've got to show that you're using these formulae. I think the likelihood is in an exam, it's not going to use numbers anyway. It's going to be an algebraic one. But let's show what we're doing to make sure we get the marks. And then once you've done that, you can stick it in your calculator and get your answer. So that's 32,774,500. So you should already have had a go at question 1 from the exercise. Now, it is in the pack on page 8, but you can also find it in the Active Learn book. You are now going to have a go at doing question 6, because they are ones of this type. Okay, make sure you're confident with these, and next lesson we will be looking at some more algebraic ones with a whole load of factorising. So that's something else to practice before then.